So most everyone's nav sort of looks like this right now. We enter in an infinite loop, so it'll keep on repeating this process. Um, and then we'll call in a choose path, which will do a full big scan and figure out what the best choice is. If there's a path forward, then we go forward. And we set 18, which is one wheel rotation, because each wheel has 18 spokes. So that's the encoder just checks for how many spokes pass the sensor. So that's one rotation. And then we'll do right or left if the choose path doesn't see a path forward, but it says turn right or left. We'll go through that. And then the loop repeats, and I'll do another full scan. And so it's really slow. If there's a lot of open space in front of me, instead of just driving for a while until there's a problem, I'm just going to chunk a little bit at a time. And so how do we change this so we can cruise, that we can just keep on driving while checking the sensor at the same time? That is possible. So you can't do it with an encode, though. An encode, the robot is thinking, it's counting these 18. And because the brain is working on this problem, on counting, the brain can't check in front of itself at the same time. But if we just tell it to go forward, just real simple, just drive forward, it'll power on the motors, and then it doesn't need to think about changing anything. So even while the motors are receiving power and driving forward, the brain is freed up to do a little thinking. So it'll look like this. So choose path. So if things are clear forward, and some of you don't use the choose path. Some of you will check while self dot is clear. A lot of you have that. You'll have another loop inside here. So as long as I'll do a quick check in front of me, and if it's clear, then I'll just go forward. So it's not self.forward. This is a method that's built into the GoPiGo API. So that's just telling the GoPiGo, just start driving. Well, no. Actually, that's not going to be the best. Let's do self.cruise, and let's just make a cruise method right here. Actually, you know what? Back all of this up. Hold on a second. Because I'm doing this inside the parent, which is not what I'd want to do. So if I'm building it in the student path, cool. So while it's clear. So let's first start with a while true loop, just so we can keep on repeating this. I don't need any of this, and I'll make another define cruise. There we go. And so this is just, I'll make a while true loop here, so an infinite loop. So actually, and I'll start going forward right away. So start driving forward, and then while true, while you're driving forward, check to see if there's something in front of me. So if ultrasonic ultrasonic sensor is oh yeah, distance, and 15. So we have the ultrasonic distance sensor plugged into port number 15. So if you make this command, that's how it calls the sensor and gets what's in front of it. And if the distance is less than our self dot stop distance, and that's whatever the stop distance is up at the top. This is what's called an instance variable, and right now anything closer than 20 centimeters is a problem, and And if you want to be even safer, if you make this like 25 or 25, now that it will stop sooner rather than letting it get even closer. So if I find, oh, where did I put that? There. Oh my goodness. Okay, there we go. Cruise. So if I take the distance and it's less than my stop distance, then I'm going to brake, which means get out of this true loop. And then I'll do self.stop. I'll stop right away. And then I don't want to keep on checking so often, so I'll use a time.sleep. This we might need to change that. That's a super small time to wait, but maybe that'll work. And actually, before I start driving forward, I'll also make sure my servo is looking at the midpoint. So at my self.midpoint, and I need to give that time to work. So I'll give that 1/5 a second as well. I mean, yeah. That's not 1/5 a second. It's 5/10 of a second. Of course, no, 5/100 of a second. Yeah. All right. Anyway, so look at my midpoint. So look dead ahead of me. Give myself 5/100 of a second to make that change. Then just start driving forward, and then enter in a loop where I check to see what's in front of me, and if it's closer than my stop distance, then if the stop distance is greater than what's right in front of me, that's a problem. Brake out of this and hit the brakes. Otherwise, if that's not true, then wait another 5/100 of a second before repeating and checking again. So this is a cruise. So you can do, I mean, now you can implement that. You could do it in a couple different ways. One is if self is clear. If it's clear in front of me, then start my cruise. So self.cruise. So if it's clear in front of me, get cruising. If it's not clear in front of me, then make an answer variable and it'll store self.choosePath. And now if answer is equal to left, then self.encode left by 5, and else if answer is equal to right, then self.encode right. All right. And so if it's clear in front of me, cruise on forward. If that's not the case, then stop and choose a path. Choose a path, I believe, makes the robot stop anyway. And it will do a full scan. And if it tells it to go left, we'll go left. And if it tells it to go right, we'll go right. Now, choose path is not the best way to decide the next path. There's a smarter way to do that, but we'll work towards that. Right now, let's see if we can get that cruise going. And let's add some comments. Show me you understand by adding in a note to show me that you can explain what it is the lines of code are doing.